Welcome to NX for Manufacturing Tech Tips. Today's session is on how to use volume-based 2.5D milling to program prismatic parts. This demonstration will last approximately 20 minutes, and then we'll stay on the line and open up a chat window for Q&A. With that, I'd like to turn the session over to Tom. Tom's going to do the demonstration today. Welcome, Tom.
Thank you, Aaron. Let me share my screen. And hopefully you can all see my screen.
I can see it, no problem.
Okay, perfect. So, good morning, good afternoon, everybody. Good evening, if anybody from Europe is joining. Let me try and run you through one of our new operations that we call volume-based 2.5D milling. That's specifically meant to address programming of multi-sided parts. The demonstration today will be a very simple one. Of a simple part. At the end, I'll show you that the operation can do a lot more complex stuff, but hopefully within the 20-minute time frame, I can give you a good idea of what this operation is doing. You see my fixture, and you see my my part, and I'm going to machine that out of a cylindrical blank that you see right here. And before I get started, I'll actually get the fixture out of the way, so we'll use our screen real estate a little bit better. Let me get started by introducing, by inserting a first operation. I'm taking that from the mill planner template. I'm using the floor and wall operation with IPW, so I'm going to look constantly, as you'll see, at my in-process workpiece. I'm going to use a 30 mil end mill, and I'm going to start with machining the left side of my part here. When I get into the operation, you'll see transparently presented the actual state of the in-process workpiece at this time, and I haven't done anything yet, so it's completely identical to the blank. I start by defining my floor geometry that I want to machine. I click that, and the system gives me a preview of the area it's going to cut. It's not going to cut just the face I selected, but it's going to extend that face, close the gaps in the floor of that face, and it's going to extend automatically all the way up to the blank. I'm going to specify a depth of cut of 6 millimeters, and I can put on my preview showing where the cuts are going to be made and how many cuts I'm going to get. And finally, I'm going to select to do a zigzag pattern, generate my tool path, and there it is. You will hopefully see that this is a very efficient tool path. It really knows where the material is, so it starts to cut exactly where the material starts, and it doesn't cut any air whatsoever. I'll show you that in a little bit more detail in a minute. So that was my very first operation. Next, I'll insert another operation, the same type. I'm again going to use a floor wall with IPW. I'm going to use the same tool. I'm going to machine the top of my part. And this is where volume-based 2.5D machining becomes apparent what we're doing, because hopefully you will now see that my in-process workpiece is changed, and we're showing you the state the part is in after I've cut my first operation. Again, I'm going to pick a floor face. I have my wall set to automatic, so the software will figure out what area I want to cut. I'm again going to put a depth of cut in here, and show you that that's going to result in another set of 3 cuts. But this time it's not going to cut across the entire top of the part. It's going to stop right here because material is already removed. Let me actually go in and put a floor stock in place. Let's say I want to leave 1 mil on my floor for a final finishing operation. And I'm going to change my cut pattern again to use zigzag. The final thing to do is show the cut levels again, and you will notice that I'm only going to get 2 cuts now, because with the 1 mil stock on the floor, I only need 2 cuts to remove the remaining material. I don't have to calculate that. The system does that automatically for me. And with 2 cuts, I'm roughing up that portion. And if we just quickly show what we've done on those first 2 operations using a toolpath verify, then I'm optimistic that you'll understand what we're trying to do when we say this is really looking at the in-process workpiece. So I'm going to cut the left portion of the part first in 3 cut levels without cutting any air whatsoever, and then I'm doing my roughing operation on the top, exactly 2 cut levels, and I'm leaving a mil of floor stock. So that's the basic principle of this operation. And I'll do a few more to show some additional capabilities. And then I'll explain a little bit more how this operation works and how you can configure it. As the next step, I actually want to take a much larger tool, a 63 mil cutter, and do the front of the part. Again, I'm going to select my my floor face. That's my floor face, and the system will show me the area it's going to cut for me. I can do that in a single cut, generate the tool path, and here I am. However, I don't want 2 passes. My tool is big enough. I just want a single pass, and that should do it. A single pass across the front of this part. Initially, when we were doing the testing of this new version, I was very scared because it stops in the middle. And I'm like, it's not even cutting the entire part. This is a bug. But you'll see later on that this is just our attempt to really minimize air cutting. When the tool reaches that point, it has cut all the material. It's a big tool, remember. It's got all the material that there is to cut on this face, and it can retract. It's done. And we'll see that later. So that's my 3rd operation. I'll continue and insert another operation, this time using a 10 mil tool. I'm going to do the slot. And the way I'm going to do that is I'm going to pick my floor face, just one small face, and actually going to show you the preview of the area that we're going to cut here. And we're not just cutting this small little face, we're cutting all the way across. If I would switch off my automatic walls, you will see that I'm actually going to cut everything there is to cut on that level. And we're using walls to trim the cut area. So I could in and now manually select some walls and say that's one of my walls, and you will see that my preview gets updated, and I'm now using that wall face to trim my cut area. So I'm not going into this this hole. I'm not cutting anywhere in this area. I'm not going in there. I'm extending my walls and I'm closing any gaps. And obviously, you pretty much figured out that I can do the exact same thing by selecting another wall on the opposite side, and that will give me the result I showed you initially, right? And we really don't have to click them manually. Initially, I had set it up to use the walls automatically. It will give me the exact same result. And you will see that the software picked those 2 walls based on the floor face I picked. It automatically picked the walls, so I was done immediately. The other thing I would like to show you a little bit of how this works is what kind of control we have. If I switch to my cutting parameters, you've already seen that I can switch on and off this wall extensions. So if I don't want to use my walls to trim the area, I can switch this off and cut a much larger area. But by default, we switch it on, and it infers that my intent is to just cut the slot. And you'll also see that there's a big hole in the middle, and we're cutting right across it, and that's because of our extend floor setting. We could switch that off to none and show you that we're actually also able to just cut the face that I picked, which is not going to be very useful in this case, but just showing you how the software works. I could just cut that selected face, or I could extend my floor to the part outline, as we call it, and that will make it a little bit larger. So it's extending on the bottom side and on the top side to the outline of the part, but it's really not what we want. So the default setting is to extend to the blank outline, and that will give us exactly a toolpath that will go until the end of the blank there. So I didn't change anything. I just tried to show you how all of this works. It came up with this automatically. Typically, normally all I would do is say I want a depth of cut of 4 millimeters. I want a single pass through this slot, which is hard to accomplish usually. You either get none or you get 2, and this way it will give me the result I was expecting. 2 depths of cut, single pass straight through the middle. I'll do 2 more operations, and the next one is quite a special operation, because so far you've seen me pick floors and all the wall stuff was automatic. We can do that differently as well. I can do what we call a wall only. I want to cut an area. I don't have a floor face. I just have walls, and I want to remove that area out. So in order to specify that, the first thing I'm going to do is change my tool axis setting. It's no longer normal to my first or floor face. I'm going to specify the vector of my tool axis. And I'm going to take the face normal of that face as my tool axis. Next, I'm not going to select floor geometry. I'm actually going to select wall geometry. So I'm switching off the automatic walls, and I'm manually going to select wall geometry. I don't want to pick each face at a time. I want to set my selection intent to tangent faces, pick that face, get all 3 of them that are tangent, and say done. That will now give me a preview of an area down there that that we're going to cut. There's no floor face there, but that's the area we're going to cut. I might want to do that with a follow part profile or cut pattern. Maybe I'm not extremely happy with just cutting to the bottom of that wall. Maybe I want to go 2 millimeters deeper, so I have a depth offset of 2. Hopefully you can see that that goes just a little bit deeper. And finally, let me input the depth of cut and show you the preview at the various cut levels. And you will see that, again, we're looking at the exact state of the in-process workpiece at each cut level, and that's the area we're going to cut, not more. If I generate the toolpath, I'll have a very efficient path that approaches at the right position, does a single pass, and removes that material. The last operation I want to do is finish my floor. Not very practical. I'm going to use my small tool for a reason. So I'm going to do the finish the top floor. If I can get my spelling correct. In this case, I'm going to pick a floor again. You'll see the IPW update. And if I just generate that, you'll hopefully see that, again, that too is a very efficient toolpath. We know that we've already cut the slot, so we're not going to put any toolpath on top of the slot. We're only going to cut the excess material that we still have to remove. So within 10-15 minutes, I actually created these 6 operations. I'll do a verify of my toolpath to show you what we've done. I want to show you briefly what we've accomplished with those 5 operations, and you'll see my entire toolpath. Showed you just 2 before. You'll see the very big toolpath that does a single pass, 2 cuts through the slot, the no floor operation that goes a little bit deeper, and the finishing of the top. Now, we can do a lot more complex operations. We can do slanted walls. We can do filleted tools. We can do undercutting. The key thing I want to show you is that, okay, it's nice to do such an intuitive and fast programming the first time, but what happens if I start making changes? What if I, for any reason, decided to do my wall operation as the very first one? You'll see everything will need to be regenerated because I'm changing the sequence. If I now go back into my wall-only operation, you'll see the in-process workpieces change because this is the very first operation I'm doing now. If I regenerate that, and I wouldn't have to go into the operation for that, but I'm actually now gonna get a different operation. I'll quickly show you that. I'm sure you have to get the feeling of what's happening here. Now it's my first operation, so I have to start a lot higher up in my in my coordinate system, and because I didn't cut with the big tool across the front of the part, I actually need 2 passes with this small tool to remove the material. So all I've done is put the operation first and regenerate it. That's all I've done. If I now put my top operation second, I could go and regenerate it, right? Takes a second, and initially this part on the left was already cut and I didn't have to go there. Now I actually have to go there because it's my second operation. If I do my finishing operation next, if we jump in, just to show the IPW again, you'll see that that's the state of my IPW now, completely different from my previous situation. If I now do my finishing, then my slot isn't cut yet in the middle. So this time I'm going to have a different toolpath that's going to cut straight over the slot because there's still material, right? So that's the basic principle of volume-based 2.5D machining. If we do the slot next, and look at the original toolpath and the new one, you may see there was air on the left side here. Now there isn't. So if I'm going to regenerate my toolpath, I get a different toolpath. It starts a little bit earlier because we didn't cut this side yet, right? I'll do the front next. Again, my IPW looks different. It looks significantly different. I still want to have a single pass across that front of the part. The software will give me that, but it's now under a slightly different angle. I had my angle settings to automatic, so it's going to cut in a different angle to really have a shortcut and do all of that in a single operation. And the last operation is then my left part, and I just generate it because I know where I'm at. So this basically concludes what I wanted to show you. The changes at the end were very rough, But what I want you to take away is that at no time did I create boundaries. I didn't have to change my boundaries because my change in operation sequence mandated something like that. Or if I didn't update my boundaries, my cutting wouldn't be efficient. I get a very efficient toolpath by just changing the sequence. My operations will adjust accordingly, cut very efficient, and they're very simple and easy to define. So with that, I'm past my 20 minutes, handing it back over to Aaron.